In this video, the learner will use properties of squares to solve problems. So far, we've covered all of these different types of quadrilaterals: trapezoids, trapezium, parallelograms, isosceles trapezoids, rectangles, and rhombi. Lastly, when rectangles and rhombi merge together, then we have squares. So let's go over the definition of a square. A square is a quadrilateral with 4 congruent sides and 4 right angles. A square is a regular quadrilateral, which means all of the angles and all of the sides are congruent. The properties of a square are that all properties of rectangles and rhombi apply. So it being a rectangle means we have 4 right angles. Being a rhombus means we have 4 congruent sides. And because it's a rectangle and a rhombus, we have all the properties of then kites and trapezoids. So we have the diagonals that bisect each other. We have congruent diagonals because of it being a rectangle. We also have that the diagonals are perpendicular because it's a kite. Now, because the diagonals are congruent and are perpendicular, the pieces here of the diagonals are all congruent. So the diagonals cut the square into 4 congruent right isosceles triangles. So you can see here, this triangle is a right triangle because the diagonals are perpendicular, and the 2 legs of that right triangle are congruent because they are pieces of the diagonal. Now, this Venn diagram illustrates the relationship between rectangles and rhombi. A square is a parallelogram with 4 congruent sides and 4 right angles. Remember, a parallelogram with 4 right angles is a rectangle, and a parallelogram with 4 congruent sides is a rhombus. Therefore, a parallelogram with both of these properties is a square. I want you to use properties of squares to be able to solve A through D here. And also use properties of squares to solve for x in both of these problems. Here we're going to determine if the given coordinates create a rectangle, a rhombus, or a square. So number 1, we have J at 5, 0, K 8, negative 11, L at negative 3, negative 14, and K at negative 6, positive 3. So here is that quadrilateral. It kind of looks like a square, but you do have to prove that it is a square. So in order to prove a quadrilateral is a square, you must prove that it is both a rectangle and a rhombus. And we've gone over ways to do both of those things. And then I want you to prove that it is a rectangle, rhombus, or square with Q, R, S, and T.